Good afternoon, grade 12s. Welcome to this revision program this afternoon. We're going to focus on financial mathematics. And you may remember that in term 3 this year, you did a lot in connection with financial mathematics. Now, if you focus on the monitor, you'll notice that financial mathematics counts for 15 marks in mathematics paper 1. And in our revision booklet, from pages 4 through 7, you have many examples that you can work through that will really sharpen your skills in connection with financial mathematics in paper 1. Please note that all financial mathematics content from grades 10 through to grade 12 will be assessed in the grade 12 final examination. A formula from grade 11 that you learn for the first time that does not occur on the information sheet is the effective and nominal interest rate formula. Please make sure that you go through this. That formula, you may recall, says that 1 plus IEFF is equal to, round brackets, 1 plus I nom divided by m, close round brackets, to the power m. Well, what is meant by all of this? Let us review. The I in that formula stands for the interest rate per period. The N stands for the number of periods. IEFF is the effective annual interest rate. There we have it right here. And the I nom is the nominal interest rate that is quoted as an annual interest rate. And then the M is the number of times the interest rate is compounded in 1 year. Right? So that's a grade 11 concept that can come up for examination in the grade 12 exam. Once again, that formula is not on the formula sheet, so make sure that you go through that. Moving on, you may remember from grade 10, we did the following important points into grade 11. The simple interest formula, which is found on the formula sheet, is given by this formula: A is equal to P, round brackets, 1 plus IN, close round brackets. The compound interest formula is A is equal to P, round brackets, 1 plus I, close round brackets, to the power N. Then we move to depreciation formulae. You may remember that depreciation is a concept that always creeps in when we're dealing with an asset. So if a company buys computers or they buy vehicles, well, those assets start getting older. In other words, we say they are depreciating in value. They are no longer their original value. They're actually getting older. And so there's a formula for both types of depreciation that we deal with. The first type, you may recall, is called straight line depreciation. And the other type is called reducing balance depreciation. Well, what are those formulae? Here they are in review. Firstly, straight line depreciation is given by the formula A is equal to P, round brackets, 1 minus IN, close round bracket. And reducing balance depreciation is given by this formula. A is equal to P, round brackets, 1 minus I to the power N. Well, let's take an example. Notice this question that is drawn from the DBE November 2014 exam paper 1, and it was question 7.1. For 3 marks, the question said, exactly 5 years ago, Mpume bought a new car for 145,000 Rand. Right? So that was the value of the car when it was brand new. Of course, the car started getting older. Well, we read on. The current book value of this car is 72,500 Rand. So obviously depreciation has set in. If the car depreciates by a fixed annual rate according, notice the point now, to the reducing balance method, calculate the rate of depreciation. Grade 12s, there is no doubt as to which formula we have to use. It's certainly not the straight line depreciation formula, because the question says according to the reducing balance depreciation formula. So if we do that, notice how we approach this. We start with our formula as it occurs on the formula sheet. There it is. A is equal to P, round bracket, 1 minus I to the power N. Then we start substituting our values. The original value of the car, which is P, was 145,000 Rand. We were told that. And the current book value is 72,500 Rand. Well, we put those values in. Then we have round bracket 1 minus I. We're looking for the interest rate, or the rate of depreciation, one can say. And then remember, it was 5 periods that were involved there. Well, if we have to divide both sides by 145,000 and then take this 1 across, essentially what we have, when we simplify everything, I will be equal to 1 minus the fifth root of 72,500 divided by 145,000. If you put that in on the calculator, you get a figure of 0,1294. That is a decimal. We now have to convert that to a percentage. Therefore, our final answer, the rate of interest will be 12.94% per annum. That is how we approach questions of this nature. Look at this question, which was drawn from the DBE June 2015 paper, question 7.2, once again dealing with depreciation. The question read, a company bought office furniture that costs 120,000 Rand. After how many years? Notice, now we're looking for the N value. After how many years will the furniture depreciate to a value of, and there's the value of A now, 41,611.57, according to the reducing balance method, if the rate of depreciation is 12.4% per annum. So how do we approach this? I can hear you saying, we use the reducing balance depreciation formula. Well done, well done. And that's exactly what we do. There we have our solution. There's our formula. A is equal to P, round bracket, 1 minus I to the power N. When we substitute for P, 120,000, and A, we know, is 41,611.57, we are told that the depreciation rate was 12.4%. When we turn that into a decimal, we divide that by 100, we're going to get 0.124. And we're looking for N. Then we simplify by dividing both sides by 120,000. So we're going to have a fraction on the left-hand side. And when we simplify this, we're going to get 0.876. Now we have the principles of logarithms playing off, right? And so if we're going to find N in this case, well, the way we do that is we say log the log of 41,611.57 over 120,000 to base 0.876 will give us 8 years. Let me show you on the calculator how we encode that, because sometimes logarithms give many learners problems. So there we have our calculator, right? And if we look for the button that's going to help us on the calculator, it's this one in the corner here. We press there. So if I had to encode, you notice on the calculator, it's flashing there at the base. According to what I've worked out, 0.876. And then I move across this way, and I need to put my fraction in, which is 41,611.57. That's my numerator. The denominator is 120,000. And when I say equal to, you notice there, I have this figure 7,999, almost recurring. And when we round that off, we have the answer, as we see on the monitor, N is equal to 8 years. Very, very easy to use that logarithmic formula. Now in grade 12, we started this concept called the future value annuity. And here is the formula. F is equal to X, which is the number of payments, square brackets, 1 plus I to the power N minus 1 over I. You may remember your teacher explained future value annuity as a certain amount of money that is put into an account every single month. And at the end of a certain time period, for example, at the end of 10 years or maybe 15 or 20 years, that amount of money is going to be given back to the individual so that they can live off the benefit of that money. That is a future value annuity, right? The other concept that was done in grade 12 is known as the present value annuity. And if you look at the monitor, there we have the formula for present value annuities. The formula P for present value annuity is equal to X, square brackets, 1 minus round brackets, 1 plus I to the power negative N. And I may just stress here that the N stands for the number of payments. Not the number of years, no, but the number of payments. How many payments are made? That's what that N stands for. We go back to the formula, and that is over I. I is in the denominator. So now let's look at questions that involve present value and future value annuities. From the DBE November 2014 paper, question 7.2.1, we have this very interesting question. It said, Samuel took out a home loan. Now, the minute we see that, grade 12s, a home loan, right? we need to start thinking in terms of a present value annuity, a loan. The home loan for 500,000 Rand at an interest rate of 12% per annum, compounded monthly. He plans to repay this loan over 20 years, and his first payment is made 1 month after the loan is granted. That qualifies as a present value annuity. It's a fixed amount that is going to be paid 1 month after the loan is granted. Now the question, 7.2.1. Calculate the value of Samuel's monthly installment. Well, very easy. We start with our formula as it occurs on the formula sheet. P is equal to x, square brackets, 1 minus, round bracket, 1 plus I to the power negative n over I. For the value of P, the home loan was 500,000, we were told that. And when we substitute everything else, notice there is the interest rate, there's the 12% converted to a decimal. Compounded monthly means that it is divided by 12. There are 12 months in every year. But look at this 240. You may be saying, now, where do I get 240 from? Well, if you notice from the question says there were 20 years. So if we just take our calculator now, and we say 20 multiplied by 12. Do you notice the answer? None other than 240. That is the amount that will go into our formula here, because he's going to make 240 payments of a certain amount. We want to calculate what is the amount that he's going to pay every month. Well, when we simplify, notice what happens. We take this denominator and we cross product it with this 500,000 here. And because the square brackets here and the x are factors, we're simply going to divide. We're going to take the square bracket to divide it. And we simplify it like this. There's our 500,000 multiplied by this denominator here. And there's the square bracket now. The denominator, we divided both sides by that in a sense. And then we work to this answer, 5,505 Rand and 43. That is the amount, grade 12s, that Samuel will have to pay every month to offset his home loan account. Moving on, we have another question. Melissa took out a loan for the same amount, that's the same 500,000, at the same interest rate as Samuel. Melissa decided to pay 6,000 Rand at the end of every month. Calculate how many months it took for Melissa to settle the loan. Notice now how we approach this. Well, there's the 500,000, after putting down our formula, of course. There's the 500,000, but now she paid 6,000. We're not calculating that anymore. We're calculating the value of N. And then we say 1 minus, round brackets, 1 plus, that's still the same. It's still 12% compounded monthly, and that is in the denominator as well, but we have minus N. Once again, we simply multiply that with that. We divide by 6,000, and now we have this square bracket on the left-hand side. When we simplify this round bracket now, it becomes 1,01. Remember, we're looking for minus N. And then what happens is, if we simplify the left-hand side here, okay, and all that, we take that across. We have this. If we tidy it up, we take this one across to make it positive, and we're going to take this one over to the right-hand side. So we're going to swap things around. Because this is negative, we take it over, it becomes positive, and because this is positive, we take this over, it becomes negative. So there's our 1 here, and this that was on the left-hand side now becomes 5/6. When we simplify that, we can now use logarithmic principles. Minus n is equal to the log of this particular to that base there. Right. In a real sense, we can also write it like this. Right. We have as an opening statement there, minus n is equal to the log, we can say, right? And we can actually put this in brackets here. We're going to have 1 minus 5/6. And to our base, we're simply going to add 1,01, right? That's putting it in the format that the calculator would like to have it in. So when we cancel that, on my calculator now, I press my log button. I'm going to encode 1,01. So that is my base. What is my number? The number in brackets is 1 minus 5/6. And when I enter that, there you see the answer, minus 180. But now notice minus n is equal to minus 180,07. To get a positive value, because we cannot have negative years, I simply multiply that here by -1 on both sides, and there I have my answer, 180,07. So, as you can see on the monitor, there we have it. Melissa settles the loan in 181 months when we round that off nicely. Moving on, we have this example. A man takes out a mortgage loan for a house. He plans to pay back the loan monthly over a period of 20 years. The size of the bond is 600,000 Rand. Right? And the interest rate is calculated at 11% per annum, compounded monthly. Calculate his monthly repayment. I can hear you saying it. It's a mortgage. We talk of a bond. It's the present value annuity formula. Well done, grade 12s. So what we do now is we write down the formula as it occurs on the information sheet. How does that formula look? Well, let's notice. Here on the monitor, we have P is equal to, there's our fraction, X, square brackets, 1 minus, round bracket, 1 plus I, close round bracket to the power minus N, close square brackets, over I. Now we substitute our values. The bond had a value of 600,000. That's our value of P. We're looking for X here, by the way. And there we have our square bracket, and we put that all in. There's the interest rate, 0,11. That's our 11%. It's compounded monthly, so once again, that's divided by 12. And notice now, we have 20 years, and we're going to multiply that by 12, right, to give us the number of payments. When we do that, it simplifies to X is equal to 6,193 Rand and 13 cents. That's what he is going to pay every month. But look at the next question. The next question says, after 14 years, this man wants to settle the mortgage loan. In other words, he wants to pay it off completely. Calculate the outstanding balance after 14 years. Now, there's more than one way to actually do this. What I've done, I've chosen to use the following method, and it works very well because it involves the future value annuity formula. I find the compound interest. I take that 600,000 and I run that on for the total number of 14 years. So notice here, that's A is equal to P, round brackets, 1 plus I to the power N. You may be saying, but what is this 168? How do I get that? Well, remember there's 14 years. If you take your calculator and you say 14 multiplied by 12, you're going to get the answer of 168. So when I put that in the calculator, all of that, the accumulated value will be 2,779,188 Rand and 23 cents. However, I have to find the future value. Remember in the previous step, I found the value of X. There it is here, 6,193 Rand 13. Put it in. I still use the same values there. There's the 168. Everything's exactly the same. And then I come to a future value amount of 2,453,817.46. Now, I take the value of A and I subtract the value of F from it. In other words, A minus F. You take those two answers there. When you subtract it, the outstanding balance after 14 years will be 325,370 Rand and 77 cents. Grade 12s, the outstanding balance calculation is an important calculation. Many papers ask learners in grade 12, how do they calculate the outstanding balance amount? So make sure that you know how to do that. Moving on, we have this question drawn from the June 2016 paper. Leboho bought a tractor for X Rand on the 1st of April 2016. Notice the following information points that are given us. She will trade in this tractor when she replaces it with a similar one in 5 years' time on the 1st of April 2021. The tractor depreciates by 20% per annum according to the reducing balance method. The price of a similar tractor increases by 18% annually. Then she calculated that if she deposited 8,000 Rand per month into a sinking fund, you may remember that that is a very good financial arrangement that is set up whenever an asset is bought, which paid interest at 10% per annum, compounded monthly, she would have enough money to cover the replacement cost of the tractor. She made the first deposit in this fund on the 30th of April 2016, and she will continue to do so at the end of every month until the 31st of March 2021. You may be saying, my goodness, what a lot of information. Don't give up and don't give in. It's very easy. Notice our questions. The first question, determine in terms of X what the book value of the current tractor will be on the 1st of April 2021. That is 5 years after it was bought. Give your answer to 5 decimal places. Well, very easy. The book value is simply going to be using the reducing balance depreciation formula, x, round bracket, 1 minus 0,2 to the power 5. When we simplify that, we can put it like that. And when we work this out on the calculator, we have 0,32768x. We're obviously going to need this in the future. Let's look at the next question. The next question says, determine in terms of x what the price of a similar new tractor will be on the 1st of April 2021. Give your answer correct to 5 decimal places. Well, now we find the book value, but now we use the compound interest formula. So we have x, round bracket 1 plus 0,18 to the power 5, and that will give us 2,28776x. We're obviously going to use that as well. Question 6.2.3 says, calculate the amount accumulated in the sinking fund on the 1st of April 2021. Well, future value formula is used here. There we have it there as it occurs on the formula sheet. 8,000, we were given that piece of information in the bullet points before. When we put the interest rate compounded monthly, remember it's 5 years multiplied by 12 will give us the 60. When we simplify that, there we have the amount accumulated in the sinking fund is 619,496 Rand 58 cents. And then finally, calculate the value of X, the price of the current tractor. Round off your answer to the nearest thousand. Well, the sinking fund is equal to the new price of the tractor minus its scrap value. So what do? Well, we found the value of the sinking fund in the previous step to be this amount. We take the new price of the tractor, which we calculated, and also the scrap value, which was the depreciation one that we did first. When we simplify all of this, the value of X amounts to 316,000 Rand. Remember, we have to divide both sides by the square bracket here to bring us to that amount. And that's how we do that. Grade 12s, in everything that we do in mathematics, whether it's statistics, whether it's financial mathematics, whatever we do, if you look at the monitor, practice, practice, practice. Plan your work, then work your plan. If we follow that, you will really do very well in your mathematics papers. So focus on your financial mathematics because you can score very good marks for that. All the best then, and in our next program, we're going to have a look at probability, in particular, the fundamental counting principle. Bye-bye.